Your engine is bleeding oil right now. Not from a failed gasket. Not from a cracked seal. From a blocked $5 plastic valve, the size of your thumb. Mechanics will never tell you this, because the truth costs $3, and the lie costs $1,200. You park your car and find a dark oil stain on the driveway. You open the hood and see oil weeping from every gasket surface simultaneously. The valve cover gasket is soaked. The rear main seal is seeping. The oil pan gasket is dripping. Your mechanic shakes his head and tells you the engine seals are worn out. He recommends a complete reseal job for $1,200. That diagnosis is built entirely on one missing piece of information. All of those gaskets and seals are being forced open by abnormal internal engine pressure. That pressure originates from one specific valve that is stuck shut with oil varnish. A $3 can of carburetor cleaner dissolves that varnish in minutes. The internal pressure drops immediately. Every gasket and seal stops leaking permanently. No teardown required. No new gaskets needed. No reseal job authorized. This is the PCV valve truth. They buried inside every service manual. The engine oil leak repair industry extracts enormous revenue from a simple pressure problem. To understand the scam, you must understand how your engine breathes. Your engine is not a sealed system. The combustion process forces a small percentage of hot gases past the piston rings with every firing cycle. These gases are called blowby. Blowby gases carry hot oil vapor, unburned fuel, and combustion byproducts into the crankcase. If these gases were allowed to accumulate, crankcase pressure would build continuously. That pressure would force oil past every seal and gasket in the engine simultaneously. Engineers solved this problem decades ago with the positive crankcase ventilation system. The PCV valve is the heart of this system. It is a small spring-loaded one-way valve typically located in the valve cover or intake manifold. It allows crankcase gases to flow from the crankcase into the intake manifold under controlled vacuum. The intake manifold vacuum pulls these gases through the PCV valve continuously during engine operation. The gases get recycled into the combustion process and burned cleanly. Crankcase pressure stays at near zero, and oil stays inside the engine where it belongs. This system works perfectly when the PCV valve operates freely. The problem develops gradually over years of normal engine operation. Hot oil vapor passing through the PCV valve deposits microscopic hydrocarbon residue on the valve components. This residue is chemically identical to the varnish that forms inside neglected fuel systems. It is a polymerized hydrocarbon compound that bonds aggressively to metal surfaces. Over time, this varnish buildup restricts the movement of the spring-loaded valve plunger. Eventually, the plunger sticks in the closed position completely. A stuck closed PCV valve stops all crankcase ventilation immediately. Blowby gases accumulate in the crankcase with nowhere to escape. Crankcase pressure rises dramatically above atmospheric pressure. This elevated pressure pushes against every seal and gasket in the engine from the inside. The rear main seal experiences the highest pressure because it sits at the lowest point of the crankcase. It begins seeping oil under the continuous abnormal pressure load. The valve cover gaskets experience elevated pressure from above and begin weeping oil at their edges. The oil pan gasket experiences pressure from below and begins dripping at its seam. Every oil leak you see on the outside of your engine is a symptom of one internal pressure problem. Mechanics examine the external oil weeping and diagnose worn seals and gaskets. They recommend replacing the rear main seal, valve cover gaskets, and oil pan gasket simultaneously. This is a legitimate repair for genuinely worn seals. But on a vehicle where the PCV valve is the root cause, it is an expensive misdirection. You pay $1,200 to replace seals that were forced open by abnormal pressure. The PCV valve remains stuck and untouched. Within 6,000 miles, the new seals are weeping oil again from the same unresolved pressure problem. You return and pay again. This cycle repeats until someone checks the PCV valve first. Carburetor cleaner is a powerful blend of solvents, including acetone, toluene, and methyl ethyl ketone. These solvents are specifically formulated to dissolve polymerized hydrocarbon varnish deposits. The varnish choking your PCV valve is chemically identical to the deposits these solvents target. When carburetor cleaner contacts oil varnish, the solvent molecules penetrate the polymer structure. They break the intermolecular bonds, holding the varnish matrix together. The solid varnish dissolves into a fluid compound that can be flushed away completely. The spring-loaded plunger inside the PCV valve is freed from its varnish prison. It resumes its normal spring-loaded oscillation under intake manifold vacuum. Crankcase gases begin flowing through the valve immediately. Crankcase pressure drops back to near zero within minutes of engine restart. The abnormal pressure load on every seal and gasket is completely eliminated. The seals and gaskets return to their normal, relaxed sealing position. The oil leaks stop permanently because the root cause has been chemically eliminated. This is not a band-aid solution. This is root cause elimination through targeted solvent chemistry. The entire repair costs $3 and takes 15 minutes. Industrial solvent engineers have used these exact compounds to dissolve varnish deposits for decades. Fuel system cleaners, injector cleaners, and carburetor cleaners all use this same solvent chemistry. The only reason this procedure is not in your owner manual is because it eliminates a $1,200 repair bill. Subscribe right now because this series is systematically eliminating every profitable repair myth. Next week, we expose the faded exterior plastic trim industry completely. We reveal the $4 boiled linseed oil that permanently restores sun, bleached black plastic trim. Following that, we expose the air conditioning mold cartel and the $2 alcohol spray that kills evaporator mildew. Share this with every driver currently watching oil drip from their engine onto the driveway. Every view takes revenue directly from the unnecessary reseal industry. Stay right here because the PCV valve cleaning protocol begins immediately. You must understand exactly what a stuck PCV valve does to your engine internals. Your engine displaces a specific volume of combustion gases past the piston rings every minute. On a healthy engine at highway speed, this blow-by volume is small but continuous. A functioning PCV valve pulls these gases out of the crankcase as fast as they accumulate. Pressure stays balanced, and every seal operates within its designed load parameters. Now freeze the PCV valve completely shut. Blow-by gases accumulate in the crankcase at the same rate, but cannot escape. The crankcase is a sealed cavity below the pistons, bounded by the engine block and oil pan. As gas pressure builds, every flexible boundary of this cavity experiences outward force. The rear main seal is a lip seal surrounding the crankshaft, where it exits the back of the engine. It is designed to seal against normal internal pressure with a light spring load. Elevated crankcase pressure exceeds the spring load and forces oil past the seal lip. Oil begins seeping along the crankshaft surface and dripping from the bell housing area. Mechanics see this and immediately diagnose rear main seal failure. Rear main seal replacement requires transmission removal on most vehicles. Transmission removal adds 6 to 8 hours of labor to the repair. A rear main seal replacement with transmission removal costs $800 to $1,200 in labor alone. The new seal is installed and holds initially because the crankcase pressure briefly equalizes during the repair. But the PCV valve is still stuck. Pressure rebuilds within weeks. The new rear main seal begins seeping within 10,000 miles. Meanwhile, the valve cover gaskets on top of the engine experience the same elevated pressure from the crankcase vent ports. These gaskets are compressed fiber or rubber seals that maintain their seal under normal pressure. Elevated pressure works its way through the gasket material at its weakest compression points. Oil weeps from the valve cover edges and bakes onto the hot exhaust manifold. You smell burning oil every time the engine reaches operating temperature. Mechanics quote $300 to $500 to replace both valve cover gaskets. The oil pan gasket on the bottom of the engine experiences direct crankcase pressure from above. It begins seeping at its seam and drips onto the exhaust system below. You now have simultaneous leaks at the top, bottom, and rear of your engine. The total repair estimate approaches $2,000 for gaskets and seals across 3 separate locations. Every single leak originates from one stuck valve the size of a soda can cap. A valve that costs $8 to replace new, or $3 to clean chemically. The diagnostic failure here is not accidental. Checking the PCV valve first eliminates the entire $2,000 repair diagnosis instantly. No shop wants to eliminate a $2,000 repair with a $3 can of solvent. Here is the exact PCV valve cleaning protocol. Step 1. Allow the engine to reach full operating temperature and then shut it off. A warm engine has thinner oil, and the PCV passages are more receptive to solvent penetration. Allow the engine to cool for 15 minutes before touching any components. Step 2. Locate the PCV valve on your engine. On most engines, it sits in a rubber grommet in the valve cover. It will have a small rubber hose connecting it to the intake manifold. Some vehicles locate the PCV valve inline in the breather hose itself. A quick search of your specific vehicle model will confirm the exact location in seconds. Step 3. Firmly grip the PCV valve and pull it straight out of its rubber grommet mounting. Disconnect the rubber hose from the valve end. Step 4. Hold the PCV valve up and shake it next to your ear. A healthy PCV valve will rattle freely as the internal plunger moves back and forth. A stuck PCV valve will be completely silent, with no rattle whatsoever. Silence confirms varnish has locked the internal plunger in place. Step 5. Place the PCV valve in a small metal container. Pour enough carburetor cleaner to fully submerge the valve completely. Allow the valve to soak in the solvent for a minimum of 30 full minutes. For severely varnished valves, extend the soak time to 2 full hours. Step 6. After soaking, remove the valve and shake it vigorously next to your ear again. You should begin to hear the internal plunger rattling freely as the varnish dissolves. If the rattle is still absent, return the valve to the solvent for another 30 minutes. Step 7. Once the plunger rattles freely, use a small wire brush to scrub the exterior of the valve. Remove any remaining varnish residue from the valve body and port openings. Step 8. Rinse the valve thoroughly with fresh carburetor cleaner to flush dissolved varnish completely. Hold the valve up to light and confirm the interior port is visibly clear and unobstructed. Step 9. Allow the valve to air dry completely for 15 minutes before reinstallation. Step 10. Push the cleaned PCV valve firmly back into its rubber grommet until fully seated. Reconnect the rubber breather hose to the valve port securely. Step 11. Start the engine and allow it to idle for 5 full minutes. Place your hand over the open end of the breather hose momentarily while the engine idles. You should feel a steady vacuum pulling at your palm, confirming the PCV system is flowing. No suction means the valve is still restricted and requires additional soaking. Strong, steady suction confirms full crankcase ventilation has been restored. Step 12. Drive the vehicle normally for 1 full week before evaluating the oil leak situation. Crankcase pressure drops immediately, but existing oil seepage on external surfaces takes time to dry. Clean the engine exterior with degreaser after 1 week to remove existing oil film. Observe for fresh oil seepage over the following 2 weeks. In the majority of cases where PCV varnish was the root cause, the leaks will have stopped completely. You just eliminated the root cause of a $1,200 engine reseal job for exactly $3. This is a direct assault on the diagnostic shortcut that costs drivers billions annually. Industrial solvent chemistry has dissolved polymerized varnish deposits for decades across every mechanical industry. Fuel system engineers, carburetor rebuilders, and injector cleaners all rely on this identical chemistry. The automotive service industry chose to ignore the root cause because root cause elimination is not profitable. Their engine reseal revenue collapses against $3 of hardware store solvent chemistry. Share this with every driver currently watching oil drip from their engine. Share it with anyone who has been quoted for rear main seal replacement. Every view pulls another dollar from the unnecessary reseal machine. Every subscription keeps this chemistry knowledge permanently free. In the next video, we completely expose the sun-faded plastic trim replacement industry. We reveal the $4 boiled linseed oil that permanently restores bleached black plastic trim to factory condition. We show you exactly why Trim Restorer sprays are a 6-month subscription service you never agreed to. Stay disciplined, stay informed, and always check the PCV valve before authorizing any oil leak repair.